Imagine you're a pilot in 1945. You're flying over crystal blue water between Florida and Bermuda, when all of a sudden, your instrument starts spinning and your compass goes haywire. This is the moment no one ever expects. Your final radio transmission is calm, almost too calm. You say something that will haunt investigators for decades. We don't know where we are. Everything is wrong. The water below is not blue anymore. It's milky, foaming, stretching for miles. Then, nothing. Your plane vanishes. 14 men disappear without a trace, and this becomes known as the Bermuda Triangle. But here's what nobody talks about. While everyone's obsessed with what disappears above the water, almost no one asks what's waiting below it. Because the ocean floor of the Bermuda Triangle isn't just a graveyard for ships and planes. It's a living, breathing trap. A place where the geology itself creates conditions so bizarre that evolution went completely off the rails. Where methane erupts from the seafloor in massive bubbles that can sink ships in seconds. Where creatures have evolved in isolation for millions of years, cut off from the rest of the ocean by underwater mountains and chemical barriers. And where some of the largest, strangest organisms on Earth have been hiding in plain sight. So today, we're not talking about disappearances. We're talking about what stays, what lives, and what's been evolving down there while we've been staring at the sky, because the real mystery of the Bermuda Triangle isn't what vanishes, it's what can never leave. The Bermuda Triangle covers roughly 500,000 square miles of ocean between Miami, Bermuda, and Puerto Rico. And while conspiracy theorists love to talk about aliens and magnetic anomalies, the actual ocean floor here is way stranger than any theory. Because this region sits on top of one of the most geologically active and unstable underwater landscapes on the planet. First, you've got the Puerto Rico Trench, the deepest part of the Atlantic Ocean, plunging down to 28,232 feet. That's over 5 miles straight down. For comparison, the average depth of the Atlantic is only about 12,000 feet. So this trench is more than twice as deep as the surrounding ocean, creating a massive geological scar in the seafloor. But depth alone doesn't explain what's happening here. What makes the Bermuda Triangle unique is what's underneath that depth. The entire region sits on a complex system of underwater plateaus, ridges, and most importantly, massive methane hydrate deposits. These are essentially frozen pockets of methane gas trapped in ice-like structures on the ocean floor. And when they destabilize, they don't just melt, they explode. While the exploding methane theory is still debated by scientists, the seafloor proves that something violent is happening. We've found craters half a mile wide, blasted out by sudden methane eruptions. If a ship was caught in one of these gas burps, it wouldn't just sink, it would lose the very physics that keeps it afloat. Water saturated with gas loses its density. A ship floating on normal water would drop like a stone if it suddenly found itself floating on a layer of bubbling methane. No time to send a distress signal, no time to react, just gone. But while methane eruptions might explain some disappearances, they also create something else entirely, an ecosystem. Because where there's methane, there's food. And where there's food in the deep ocean, things get big. Let's descend. Starting at the surface, the Bermuda Triangle looks completely normal. Turquoise water, tropical fish, the occasional reef shark. This is the epipelagic zone, the top 656 feet, and there's nothing particularly unusual here. But once you pass that threshold and enter the mesopelagic zone, the twilight zone, things start to change. The water gets darker, colder, and the pressure starts to climb. This zone extends down to about 3,280 feet, and it's here that we encounter our first clue that something's different in the triangle. Because the density of life here is abnormally high compared to other parts of the Atlantic. Schools of fish, swarms of jellyfish, dense clouds of plankton. It's like the entire food web is concentrated in this region, and scientists believe it has to do with nutrient upwelling from the deep trenches below. But it's not just quantity, it's size. Jellyfish here grow noticeably larger than their cousins in other parts of the Caribbean. Squid appear in sizes that border on the edge of what's typical for the species. And as we descend further, past 3,280 feet, into the bathypelagic zone, the midnight zone, the size disparity becomes even more pronounced. At around 4,000 feet, you might encounter something that looks like a living sheet of translucent muscle drifting through the darkness. This is a species of salp, a gelatinous filter feeder that forms colonies by linking together into chains. In most parts of the ocean, these chains reach maybe 10 to 15 feet long. In the Bermuda Triangle, researchers have documented salp chains exceeding 50 feet. No one's entirely sure why they grow so large here, but the leading theory involves the methane. See, methane seeps on the ocean floor don't just release gas. They create entire chemosynthetic ecosystems. Bacteria consume the methane and convert it into organic compounds, which then feed other organisms, which feed larger organisms, and so on up the food chain. It's like a secondary food web running parallel to the normal one, powered not by sunlight, but by chemical energy from the Earth itself. And in the Bermuda Triangle, with so many active seeps, this chemosynthetic buffet is basically running 24/7. Which brings us to one of the strangest residents of the triangle's deeper zones, the giant tubeworm. Now, you might be thinking, wait, I thought those only lived in the Pacific near hydrothermal vents. And you'd be mostly right, but researchers have found cold seeps here, underwater oases where life ignores the sun. In these chemical fields, we find tubeworms that grow so slowly they are essentially immortal. They don't have mouths or stomachs. They have evolved to let bacteria live inside their bodies, turning poison into life. They are living batteries of the deep. These things can reach over 6 feet tall, living in clusters around methane vents at depths exceeding 15,000 feet. How did they get here? The leading theory is that millions of years ago, when the Atlantic was narrower and ocean currents were different, tubeworm larvae drifted across from Pacific populations and found a suitable habitat in the triangle's methane-rich environment. And because the conditions here are so stable, constant temperature, constant methane flow, constant darkness, they've been thriving in isolation ever since, cut off from the rest of their species, evolving separately, trapped by geography and chemistry. And they're not alone. At around 6,000 feet, you start encountering the mussels, Bathymodiolus childressi to be specific. These aren't your typical seafood menu mussels. These are giants, some growing shells over a foot long, and they live exclusively around methane seeps. Like the tubeworms, they don't eat in the traditional sense. Instead, they house bacteria in their gills that convert methane and hydrogen sulfide into nutrients. It's a partnership. The mussel provides a home, the bacteria provide food, and together they thrive in an environment that would kill most other life forms. But here's where it gets interesting. These mussel beds aren't just sitting there. They're creating habitat. Crabs scuttle through them. Snails graze on the bacterial mats. Shrimp cluster around the edges. And fish, specifically a species of deep-sea eelpout, patrol the colonies looking for prey. The methane seeps have essentially created oases of life on an otherwise barren seafloor, islands of biological activity in a desert of mud and rock. And the creatures living in these oases, they can't leave, because if they drift too far from the methane source, they starve. The bacteria that keep them alive need methane to survive, and methane is only available at the seeps. So these animals are geographically locked to specific patches of seafloor, sometimes just a few hundred feet across. Generation after generation, evolving in isolation, unable to migrate or interbreed with populations elsewhere. It's evolutionary entrapment. But we're not done descending yet, because the Puerto Rico Trench goes deeper, much deeper, and at around 20,000 feet, we approach the boundary between the abyssopelagic and the Hadal zone, the abyss. The pressure here exceeds 600 times atmospheric pressure. The temperature hovers just above freezing, and the only natural light comes from bioluminescent organisms drifting through the darkness like living stars. Food is so scarce that life moves in slow motion, waiting for anything edible to drift down from above. And it's here, in this crushing darkness, that we find some of the region's most bizarre deep-sea residents. In 2018, cameras exploring the Puerto Rico Trench captured footage of giant isopods, creatures that look like deep-sea roly-poly bugs, except these were abnormally large, over 2 feet long, noticeably bigger than specimens found anywhere else in the Atlantic. The methane seeps may provide a more reliable food supply than the surrounding seafloor, giving these scavengers access to calories rarely available in the deep. But they're not alone down here. At depths exceeding 20,000 feet, researchers documented what they call supergiant amphipods. In most of the ocean, these shrimp-like crustaceans measure maybe an inch or two. In the triangle's trenches, they reach over 13 inches long, bigger than a human hand. And they're not gentle. They're aggressive scavengers that swarm anything that falls to the seafloor, stripping it to bone in under an hour. And here's the creepy part. These amphipods are trapped just like everything else. They've evolved to survive extreme pressure, which means they cannot survive outside their pressure-adapted environment. If you brought one to the surface, it wouldn't just die. Its cell membranes would lose integrity. Its proteins would unfold. At the molecular level, it would turn into something that's no longer recognizable as an organism. Not dead, but dissolved into biological components. It doesn't just die. It ceases to be an organism. But the strangest discovery came in 2015, when NOAA expeditions encountered unexplained gelatinous material on the deep sea floor. Researchers dubbed it blue goo, a strange pulsing mass that didn't match any known species at the time. But even stranger was what they found nearby, an aplacophoran, a shell-less, worm-like mollusk covered in thousands of microscopic calcified spicules. Evolution stripped it of a shell and replaced it with an entirely different kind of protection. It crawled across the sediment like something out of a nightmare, probing the mud with its eyeless head, searching for food in total darkness. So why do these trench environments create isolated populations of oversized, bizarre deep-sea life? It comes down to three things working together. First, methane seeps provide a constant source of energy that doesn't exist across most of the deep sea floor. Second, extreme depth and pressure isolate populations within trench systems, creating natural biological barriers. And third, lower predator density compared to surface ecosystems allows organisms to grow slowly over long lifespans without constant evolutionary pressure to stay small and fast. Put those together and you get a biological trap. These creatures can't leave because the environment outside won't support them. They're adapted for this specific, methane-influenced corner of the Atlantic. If conditions ever change, they'll go extinct. Their entire existence is tied to one patch of seafloor. What's particularly unsettling is that only a small fraction of this region's deep seafloor has been directly explored. We have higher resolution maps of Mars than of much of Earth's deep ocean floor, including areas beneath one of the most famous regions on the planet. But there's one more mystery this region holds. The Bermuda Triangle overlaps with the Sargasso Sea, the only sea on Earth without land borders, and every single European eel and American eel on the planet travels thousands of miles to this specific region to spawn. We've tracked them migrating from rivers in Europe and North America. We've documented them swimming across entire oceans to reach this location. But we've never seen them actually spawn. They are believed to die afterward, though the process has never been directly observed. We just find the babies, tiny, transparent larvae, drifting away on ocean currents, beginning their journey back to freshwater rivers. The triangle is a biological destination for a ritual we still don't understand. Millions of eels, driven by instinct, converging on one patch of ocean to reproduce and then vanish. The truth is, the Bermuda Triangle's floor is a graveyard of things that failed the pressure test. Ships that sank, planes that crashed, equipment that imploded. But for the things that live there, the supergiant amphipods, the needle-covered mollusks, the extremely long-lived tubeworms, it's not a graveyard, it's a sanctuary. They aren't trapped by the mystery, they're protected by it, because as long as we're looking for ghosts in the sky, we'll never find the true masters of the Atlantic deep. So the next time you hear about a mysterious disappearance in the Bermuda Triangle, remember, something's down there. Maybe not aliens, maybe not ghosts, but something real, something massive, something that evolved in isolation for millions of years and has no intention of ever leaving. Because in the Bermuda Triangle, escape isn't an option. Not for the creatures that live there, and maybe not for anything that falls into their world. As always, thank you for watching, and we'll see you next time on Deep Blue Marble.